Have you ever seen a platform rise straight up, like magic? That's no magic, it's a beautifully engineered system called the Scissor Lift Mechanism. In today's deep dive, we'll unfold the genius behind this lift design. The scissor lift uses a system of cross-linked bars arranged like an X or a pantograph. When force is applied to one end of the linkage, either by a hydraulic piston, screw actuator, or motor, the X sections expand or collapse vertically. The key principle? Mechanical advantage through geometry. The lower the scissor arm's angle, the more horizontal force is required. As the angle increases, the vertical lift grows rapidly. This allows precise, smooth lifting, often with minimal power. Scissor lifts can be powered manually, electrically, or hydraulically. Some use a central screw, others rely on dual hydraulic pistons. The frame design and number of X units affect both height and load-bearing capacity. When designing a scissor lift, engineers consider weight distribution, actuator stroke length, pivot joint strength, and base stability. A small miscalculation can cause instability or binding in the arms. You've seen scissor lifts in construction sites and warehouse, but they are also used in aerial work platforms, stage equipment, elevating beds, industrial lift tables, material handling systems, hospital beds, folding ladders, and even inside your car's jack. So the next time you see a scissor lift, you know, it's not magic, it's mechanics. If you enjoyed this deep dive, hit the like button and subscribe for more. Next up, the slotting machine and its clever quick return mechanism. Stay tuned.